our absentees. All right, in a right triangle, the side opposite of the right angle is called the hypotenuse, which you guys should be aware of this. That's also your longest side. The other two sides are called legs. Okay. We've learned that ASS and SSA are not theorems that we can prove triangle congruence. Hi, Justin.
Hello.
Welcome back.
Yeah.
I don't want Justin. All right, so we learned that ASS and SSA were not ways that we can prove triangle congruence, right? No. Bad word, forwards, backwards. However, we are going to learn today the hypotenuse leg theorem, which if you were to look at two triangles that were congruent by the hypotenuse leg theorem, let's just sketch two right triangles. Okay, those don't appear congruent at all, but just pretend. The hypotenuse leg theorem says that if the hypotenuse is congruent to the hypotenuse and one leg is congruent to the other corresponding leg, that will be enough to prove the triangles are congruent. Now, if you were to look at this and actually write your angles and your sides, you would say ASS, ASS, and we would say, oh no, they're not congruent. Okay, but this is called the hypotenuse leg theorem. This only works for right triangles. Okay, if they are not right triangles, then you can't use this theorem because you wouldn't have a hypotenuse, you wouldn't have a leg. Now, can anyone think of why the hypotenuse leg theorem would actually work? What's something we know about right triangles and their side lengths? Maybe a formula, perhaps, we know. I can find side lengths of a right triangle. Brett? The Pythagorean theorem. So, like, let's just throw in numbers. Let's suppose I knew this was 3 and this was 5. And I knew this was 3 and this was 5. Okay? Couldn't we do the Pythagorean theorem to prove that the other two legs were congruent? If we did the Pythagorean theorem, and you guys might remember the triple, the 3, 4, 5. The Pythagorean theorem would yield that this side is 4. The Pythagorean theorem would prove that this side is 4, and then we would have congruent sides. So then we would have SSS, really, is the reason that this theorem works. But so that in a proof you don't have to do the Pythagorean theorem and then substitution and all that stuff, we will use the hypotenuse leg theorem. Okay. Now, because it has to be a right triangle, in our proof we're going to have to state that the triangle is a right triangle before we use this theorem. Okay, but it does actually spell ASS if you were to label it, just remembering that we are calling it the hypotenuse leg because it only works for right triangles. All right, so in order to use the HL theorem in a proof, you must show 3 conditions are met. Number 1, you have to show that there are 2 right triangles. So in our proof, one of our statements will be triangle ABC and triangle DEF are right triangles. Definition of a right triangle. What is the definition of a right triangle? How would we know something is a right triangle? It's a triangle that, Maddie? Has one right angle. Exactly one right angle. All right, the second thing we have to prove is that the triangles have congruent hypotenuses. And that would be the hypotenuse part of the hypotenuse leg theorem, so we probably have to prove 2 legs are congruent. Therefore, we'd have hypotenuse leg. So the proofs themselves are going to be really similar to what we've done in the past. We'll mark shared side, vertical angles, whatever the given might be. But as soon as you realize that it spells ASS, then you will realize that you're going to have to rethink your game and use HL instead. So, proof number 1. Already marked for us is the given. Segment WJ is congruent to ZK. And then it also says angle W and angle K are right angles. Notice they didn't give us perpendicular, where we'd have to state that they're right angles. They're actually giving us that they are right angles. And they want us to prove that triangle JWZ is congruent to ZKJ. So most of you would add in a marking, right, in the middle, shared side, so let's go ahead and do that. JZ is congruent to JZ. Reflexive. Okay, and then normally we would just say what the triangles are congruent because we have three things, but we should notice that we have A, S, S, which cannot be a reason. So, if we have ASS but it's a right triangle, we probably have the hypotenuses are congruent and the legs are congruent. So we have HL. Now, the reason that there's 4 lines instead of 3 is that in order to use the hypotenuse leg theorem, you have to prove that you have a pair of congruent legs, a pair of congruent hypotenuses. The other one was that we have to state that they are right triangles. So in my proof, I'm going to have to say, before I say the triangles are congruent, I have to state that they are right triangles, which they are because they have a right angle. So triangle JWZ and triangle ZKJ are right triangles. Not angles, are right triangles. The only way you can use HL is if you have 2 right triangles. And this would be the definition of a right triangle. Because they gave me that these were right angles, that tells me that there's 1 right angle in each triangle, therefore they're right triangles. So now we have all 3 parts met. We have congruent legs, congruent hypotenuses, and right triangles. So now we can say that the triangles are congruent by HL. Okay, which again stands for hypotenuse leg. And if you want to put theorem, you can, but you're not required to on these for some reason. I thought you just write ASA and all that jazz. Okay. Next one, given CD is congruent to AE, that's already marked for us. It says AD is the perpendicular bisector of CE. Now the part I really don't like about this is they already marked that in the picture for you. Normally we add in those markings and that would remind us to write that down. But they actually already marked this in the picture, remembering that a perpendicular bisector creates 2 right angles and 2 congruent segments. Okay, so you can see they put in 1 right angle. Technically, it would create 4 right angles, I should say. We just don't put the other ones in. But these would both be right angles, and then they already put in the congruent markings for us. So we go ahead and start with that. Let's go ahead and say CB is congruent to BE. And that would be the definition of a perpendicular bisector. You can use a symbol for perpendicular as well if you want. I've just been trying to write it out because some of you think that this symbol means perpendicular bisector and it only means perpendicular. All right, now we said it also forms right angles. So remember, we have to actually state that they are right angles first. Okay, so we'll say angle CBD and angle ABE are right angles. Oops. That would be the same reason as above. That's also the definition of a perpendicular bisector. Now, normally what would we say after we say they're right angles in a normal proof? Maddie? that they're congruent, because all right angles are congruent. You don't actually need to do that. Now, if you do it, it's not wrong, but you will add an additional line to your proof. If you're using HL, you don't have to tell me that they're congruent right angles. You just have to tell me that they're right triangles, and then you can use HL. So, in this instance, you would notice that you have ASS, okay, which again would indicate that we are going to use HL. Remember, to use HL, you need to have right triangles, you need to have congruent hypotenuses and congruent legs. You have to have all three things. So we do have congruent hypotenuses. Those were in the given. We have congruent legs. That was also kind of given to us with the perpendicular bisector. And so now we have to state that we have right triangles before we can use the theorem. So we'll say triangle CBD and triangle EBA are right triangles because they have a right angle in each of them. This again is the definition of a right triangle. This is the step that a lot of you will forget. You'll actually tell me that the angles are congruent, which is not wrong, but you have to have this in there also. So if you wanted to have both things just to be safe, you could. And then now we have all three elements are met, therefore the triangles are congruent by HL. All right, I'd like you guys to complete the closure.